Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. It's our last lecture together, and since we're not having a final exam in this class, so this will literally be the last time we'll all be together. So, I guess for the last time, how's everyone doing today?
Really good.
Good, thank you.
Good, thank you.
Good. Yep. So today we're just gonna have our second half of our final presentation. So we have 4 groups to go, and so each group will have about 15 minutes, just like the last time. And so if we just kind of stick to the schedule, we should end a little bit early today. Okay. And so with that, I'll go ahead and turn it over to the first group today. So our first group is going to be the Boeing 737 MAX group. And so I have the timer here and I have your rubric ready. So I'm going to go ahead and mute myself, and whenever you guys are ready, you guys can start. I'll start the timer after you move on to your introduction slide.
All right, then. Thank you. All right, so good afternoon, everyone. My name is Juan Cortez, and my group members are Marwan, Eduardo, Anthony, and Liddell. And our project is about the Boeing 737 MAX. So a brief introduction is guided by the fundamental values of ethics. Professionals are expected to demonstrate knowledge in their careers, as well as always maintaining the highest level of honesty and integrity. On August 30th, 2016, Boeing decided to create a new airplane model called 737-8 MAX. And in 2017, the Federal Aviation Administration certified it. They claimed that enough testing was done and that it would be safe to fly. Unfortunately, failure to communicate malfunctions, 2 deadly crashes occurred within the next couple of months after being certified. So just a year after being certified, Lion Air Flight 610 takes off from Indonesia on October 29, 2018. And 12 minutes after takeoff, the plane crashes into the Java Sea, killing 189 passengers. 5 months later, Ethiopian Airlines flights 302 takes off from Ethiopia on Sunday, March 10th, 2019. And 6 minutes after takeoff, the airplane crashes in Bishoftu, Ethiopia, killing 157 passengers aboard. After the 2 deadly accidents due to software malfunctions and failure to communicate, Boeing 737-8 MAX, an American technological success, soon became associated with disaster. And now I will pass it on to Anthony.
Hello, my name is Anthony. I will be reading the historical context for Boeing. Boeing was founded on July 15, 1916 in Seattle, Washington, under the name Aero Products Company. The founder, William E. Boeing, was a wealthy investor of lumber who established the company's very first headquarters from a wooden boat building plant, which was transformed into the aircraft manufacturing plant seen on the top right hand of your screen. Known for defense, space, and security, Boeing is one of the world's largest multinational manufacturers in the world, with over 160,000 employees and an estimated net worth of roughly $95 billion. Boeing currently holds 64 locations across 28 countries worldwide, allowing for it to be a global leader in the commercial aircraft market, with a little over 43% of the total market. Much of the company's revenue comes from its massive customer base worldwide, as many as 150 countries have bought or are currently purchasing Boeing products. The chart on the lower right-hand side shows Boeing's revenue growth from 2005 up to 2018. Next slide, please. On the right-hand side, you can see a pie chart of the company's revenue distribution based on its 4 sectors consisting of commercial airplanes, defense and security, global services, and Boeing Capital. The largest and greatest revenue generator for the company is their commercial airplanes, repeatedly consisting of roughly 50% or more of Boeing's revenue. Their most popular and consistently purchased aircraft being their 737, which was first introduced into market in January 1967. And now I'll pass it on to Liddell.
Like mentioned earlier, my name is Liddell, and I'm going to be focusing on the technical context of the Boeing 737 MAX. Okay, so first, let's talk about the features that are distinct to the MAX that were advertised to the public prior to the first crash. And that includes the CFM LEAP 1B engines, AT winglets, Boeing Sky interior, and the flight deck display. A combination of the LEAP engines and the stylish new winglets saves more fuel with a 14% fuel reduction. And according to Boeing, the 18 winglet is the most efficient ever designed for a production airplane due to the design and manufacturing techniques, which allow for a natural laminar flow. And as you can see, there weren't many changes done to the overall design of the airframe. The aircraft resembles very much the 737NG, its predecessor. And Boeing did this on purpose. Its goal was to maximize efficiency with new updates while keeping the aircraft the same. It was very important to them to keep commonality between the 737 family, and we'll see why later. Okay, so in terms of money, this sounds like a pretty good plane. It lowers maintenance costs, improves efficiency, increases passenger capacity and range. So what went wrong? Okay, next slide, please. Yeah, so originally the 737 was designed lower to the ground, and fitting two larger engines wouldn't be an easy task for the engineers to solve at Boeing. Because the LEAP engines were too big for the MAX, Boeing engineers decided to move the engines forwards and up a bit, just enough to get ground clearance. However, this changed the aerodynamics of the aircraft. During rare flying conditions, the nose of the plane tended to pitch up. So it would go from a high angle of attack to an even higher angle of attack, possibly making the aircraft to enter a stall. And this is where the maneuvering characteristics augmentation system comes into play, or MCAS for short. The purpose of MCAS was to sense if the aircraft was approaching a stall. And if it was, it would automatically, without any human intervention, pitch the nose of the aircraft down. The first version of the MCAS used multiple sensors and was only activated under rare conditions. But the final production only used one sensor to detect possible stalls and was more aggressive. So this is how Boeing dealt with solving their technical challenges. Now I'm going to hand it off to Marwan.
Hey guys, I'm Marwan. I'm going to talking about the economic context. So as you guys see here on the right, this is like the Boeing annual income since 2000 and until 2019. So the Boeing company was gaining like billions of dollars every year, and it was like increasing as the time passed. And so like in 2015 and 16, it was like a little bit like difference, but they still gaining billions of dollars until like in 2018, they reach up to 10.45 billions of US dollars. But in 2019, after the two crashes, Boeing loses for the first time 640 millions of US dollars. So Boeing was making the 737-8 Max. It cost it like around 121 millions of dollars, and they expecting like to gain profit from it between 12 to 15 millions only, because the price of the Boeing company, the price of the plane is like 120 million. So for any airplane company who want to buy a plane, that will cost them a lot of money. So they're giving discounts up to 50 and 55% on their planes. So they could be able to sell a lot of planes, and at the same time they will be able like to get more profit, or like at least like 20% or 25% profit. However, after the Boeing two crashes in 2018 and 19, Boeing decided to decrease the production by 20%. Boeing was making around like 52 planes a month, and it dropped to 42 only. And after the two crashes worldwide, Boeing decided to like land, or like to ground all the type of 737-8 Max, and that cost her $1 billion in just the first 3 months. To like until they found like what was happening and like what was the issue of these two crashes. Yeah, next please. Also, Boeing decided to give $100 million to the local government in Ethiopia, to the families of victims. The money won't go directly to the families. They will try to help them in education and increase like their family money, help them, support them. There's like families that lost their parents. They're like the one who is caring about the family or this stuff. So this money will be able like to make them survive for like a little bit of time. Also, the company said it expects to spend around like $4 billion more than previously budgeted to build the planes once it received the permission to do so. Also, Boeing, because of the amount of money that they lost, so they decided to take money from the capital markets. And lastly, the annual aircraft deliveries for Boeing in 2019 decreases from 806 to 345 only in 2019 because of these two crashes, and that costed up billions of dollars because most of the airline companies canceled their orders from the 737 MAX and other put their orders on hold. Next.
Hello, everyone. My name is Eduardo. I'll be talking about personnel. So both Boeing and the FAA knew that the 737 MAX could cause fatal accidents. Boeing hid the new MCAS feature from the pilots, as well as failing to acknowledge the defects that the plane had. The employees at Boeing reported violence and threats from bosses and were told things like, quote, "I am going to push you until you break." In a press conference, CEO Dennis Muhlenberg downplayed the role of the MCAS software and left a lot of questions unanswered. He was then forced to resign as CEO of Boeing. Next slide, please. After the first crash, the FAA made a risk assessment and calculated that there will be a total of 15 new crashes, meaning every 3 years there will be a new crash. Although knowing this information, they chose not to ground the planes. Resulting from that, the second 737 MAX crashed just 3 months later.
Okay, so Boeing failed to recognize that their design was flawed. They could not fit two modern big engines in an aircraft designed in the 1960s that had different needs. A shortcut was to move the engines, and that changed the aerodynamics of the aircraft. By changing the aerodynamics of the plane, it no longer behaved like a 737. This was a problem for Boeing because they advertised this plane to be just like a 737. There was no need to recertify pilots. There was no need for additional expensive training because it behaved just like a 737. If a pilot could fly any 737, they could fly the MAX. And that is why they designed the MCAS to force the MAX to be like a 737 when it really wasn't. And to make matters worse, they failed to inform the public, airlines, and most importantly, the pilots about the existence of MCAS until after the first crash. Now let's move on to analyze what principles were violated in the process of making these decisions. And for that, we're going to be taking a look at the ACM Code of Ethics for Software Engineers. Principle 1, Section 3 states that engineers should approve software only if they have a well-founded belief that it is safe, meets specifications, and passes appropriate tests. If they had to deceive the FAA in order to have the MAX certified, well, we can conclude that they were aware that the MAX was not safe from the beginning. Besides, Boeing employees didn't entirely understand the function of MCAS. So how could they approve of software that they didn't fully understand? They practically did the opposite of what this principle said. Okay, so now the next principle states that software engineers should disclose to appropriate persons or authorities any actual or potential danger to the user and the public. And so instead, they concealed the potential flaws of the MCAS and removed any description of the MCAS from the pilot's manual. That is a clear violation of this principle. So now I'm going to hand it off to Marwan.
So the impact of the ethical issue, like after these two deadly crashes, the aviation authorities ordered all airlines to land the planes of the 737 MAX until investigation ended. Also, the Southwest Airlines has announced that it has like around 34 planes, and it like landed them, and they lost around $200 million in just 3 months. Also, the American Airlines landed 24 planes, and they canceled at least 15,000 flights until August. Also, the American Airlines estimated loss of money was around like 350 million. Next. Also, the total number of cutting orders from Boeing company was around like 4,000 planes from like this type or a different time because they wasn't sure if they're gonna like continue doing the planes or not. Also, some airplanes decided to hold their orders from Boeing. Beside the 100 millions that we talked about to the families, they may like face litigation costs that could go far higher. Also, Boeing debt has basically doubled since the end of March, rising to 25.3 billions. And it has to make a deal with the nation to borrow like around 13 billion on a new credit line. Also, Boeing will have increased the interest expenses from its borrowing. Next.
So other possible ethical choices, communication. So the first step after communicating the problems in that the airplanes had would have been to ground all 737 planes and immediately do a deeper investigation and fix whatever they had. Although pilots did complain about malfunctions, no one took action, including the engineers. Following protocols and communicating could have led the engineers to act and fix any defects from the airplanes. And as the NSP Code of Ethics states, engineers shall hold paramount the safety, health, and welfare of the public. And so, if there had been better communication, the accident could have been avoided, since the problems would most likely have been fixed, and the people involved would still be alive today. Public trust would remain. Instead, it most likely fuels people's phobia of traveling in airplanes, and the company involved would have saved their reputation and people's careers. And then outlook for future situations and conclusion. If a similar situation was to occur in the future, it would be to maximize the punishment for everybody involved in hiding any information that led to the accident. And the public outcry against the companies involved will most likely send them to become bankrupt since their reputation would be tarnished. And finally, engineers should feel a sense of responsibility for the products, meaning that they stand firm in the belief in whatever they design. And that is all. Thank you very much.
Great, thank you guys. Yeah, great job. Okay, so just like everyone else, if you guys want to touch up your slides a little bit before you turn it in, you guys can do that. But I need your slides by Friday. But great job. Okay, so the next group that we have is the Chernobyl group. So is everyone here from that group?
Yes.
Okay. Yeah. So whoever has the slide, you can go ahead and share your screen.
Yeah, sure.
Okay. So whenever you guys are ready, you guys can go ahead and start. And just like everyone else, I'll start the timer once after you guys introduce yourselves.
Cool.
Oh, sorry.
Sorry. All right, cool. So the name of our project is Chernobyl. This was created by Justin, Daniel, Benjamin, Allegra, and myself, Brian. Next slide. So a little introduction. The Chernobyl disaster occurred in a nuclear power plant of Piper, Ukraine. The date was April 26, 1986. This is approximately 34 years ago. The reason of this disaster was due to testing on reactor 4 of this power plant, and testing ended up going south. The outcome was there was a huge release of radioactive particles, and these particles moved over to surrounding towns and even further. Reports vary on the amount of direct deaths caused by this incident. Some people say 40, other people say around 80. However, indirect deaths are definitely in the thousands due to being exposed to the radioactive particles. The ethical situations we're going to be focusing on is the engineers decided to reduce the water flow before the testing began, so reducing the amount of cooling in the power plant in that reactor. The sudden power adjustments once the reactor went low were sudden. Another ethical decision that was made was that the government delayed actions in admitting the true scale of the disaster 24 hours later than it should have been addressed. Next slide. So I want to show these two pictures. The picture on the right is where this all went down, where all the wrong buttons were pressed. And then the one on the left is the outcome of this event. Next slide.
All right, so a little bit about the historical context of the event. So the Chernobyl power plant was one of the largest in the world. It was located in northern Ukraine when the country was still a part of the Soviet Union. A little timeline here is in 1970, they started a construction on the small town of Pripyat, only a few miles from the nuclear plant. And this was made to accommodate the workers and families that were going to be working at the plant. In 1977, the construction of the actual plant began. And by 1983, They created 4 pressurized water reactors, and they were planning to build more. On April 26, 1986 was the actual day that the incident occurred.
Sorry. The building blocks for a nuclear power plant can be seen from the thermodynamic settings. As a nuclear reactor heats up, there's a cooling water system in place that recycles the hot water passing through and uses the steam produced in a turbine to make electrical energy. So in the case of Chernobyl, the power of the reactor was dropping dangerously low, approaching zero. So scientists and engineers wanted to rapidly increase the power, and did this by raising almost all the graphite rods, which will increase the reaction of the system. But having been low powered, the water flow in the system was slowed down, so it began to boil, meaning it wasn't reacting as well in the system. This led to much more power output of the core, so the rods were all lowered to slow down the reaction. But this step displaced the water in the reactor in just a way that there was a larger spike in energy that the system was originally not designed to handle.
So basically, the team wanted to conduct a safety test on April 25th, 1986 at 2300, and it carried on into April 26th. The timeline diagram below shows the main sequence of events. So first of all, at 1:23, while the test was in session, it was recorded that reactor 4 was operating with only 8 control rods instead of the required 15. At 1:23, this led to a spike in temperature followed by an energy surge and excessive steam generation. This overheated the reactor and triggered the first explosion. A few seconds later, also at 1:23, the second mixture of the released steam and the zirconium in the fuel rods. This explosion launched fire and debris up into the air and released radioactive particles into the atmosphere. At 1:24, the power to the reactor was cut. There were 2 immediate casualties, one worker whose body was never actually recovered, and another worker who died in the hospital due to severe third-degree burns. As you can see, this all happened within a matter of minutes, even seconds, but the decisions made leading up to this point are what doomed the reactor in the first place. Next slide.
All right, so the meltdown and its aftermath, it ended up costing billions of dollars. It was estimated to be around 235 billion for the cleanup costs due to Chernobyl. A lot of the revenue was lost from the food sources within the area due to the risk of radiation and contamination. It was the main source of income, and it was actually the worst hit by the economy. Belarus lost 23% of its land due to contamination, 20% of that being used for agriculture use. In Ukraine today, the government still spends 7% of the national budget to solving the complications involving Chernobyl. The neighboring towns around Pripyat and Chernobyl were considered Chernobyl exclusion zone because they were all contaminated with radiation and unsafe, and these are known as the 9 atom towns.
So for the personnel context, the personnel involved in this disaster were unfortunately part of or victims of the mass corruption that engulfed the Soviet Union at the time, spanning from the top to the bottom of the chain of command. There are lots of personnel that were involved in Chernobyl, but I'd like to focus on 4 individuals that had a hand on the incident. So starting with one of the senior reactor control engineers, he was a 25-year-old graduate, Leonid Topnov, from Moscow Engineering Physics Institute. He was only an engineer for 2 months with the Chernobyl power plant, and was inexperienced in the shutdown process. He skipped a step in the shutdown process, and the reactor power level dropped. His boss, Antony Dyatlov, was his deputy chief engineer. So fearing for his job, he feared a setback would endanger his position as chief engineer and hate from the station director and above in the chain of command. He demanded that they continue the test even though the power level dropped, and that Leonid bring the power level back up. This ultimately created a power surge, and due to this unsafe command, he was one of the sole contributors to the meltdown and explosion. Moving on to the station director, Viktor Bronkanov, excuse me. He was responsible for the oversight and construction of that station. He was forced to cut corners by his party and to fake results to meet quotas. He signed off on the reactor 4 without doing any safety tests being conducted on it. And the safety test being conducted on it was also rushed the day of the incident. Corruption and safety violations caused Viktor to be held personally responsible by his own Communist Party. Someone not directly involved in the explosion but did investigate was Valery Legasov. He was a radiochemist specialist and was assigned to investigate and help contain the radioactive behavior of the explosion. Instead of covering it up in a court case, he revealed to the world that the Communist Party had done what they had done to cut corners. Revealed the amount of incompetence within the party and management of the Chernobyl nuclear project. He was later awarded the title of Hero of the Russian Federation by President Boris Yeltsin.
So as mentioned before, there are several events and factors that ultimately caused the meltdown. To start, all of the engineers and operators were under the pressure of the Soviet Union to produce positive results. The first wrong decision was opening reactor 4 without the proper safety test beforehand. The key decision here was whether or not to continue the test despite dangerously low power levels. The long-term effects of the disaster are some of the most devastating results in history. So there were 2 immediate deaths, but also 31 cases of acute radiation syndrome, or ARS, in the first responders who arrived at the scene of the explosion to put out the fires. And ARS symptoms are fever, nausea, vomiting, diarrhea, seizure, and coma, and in most cases lead to death. Along with that, over 5,000 cancer deaths and 3,000 thyroid cancer cases in children under the age of 14 have been linked to the devastating exposure to radioactive particles. To this day, we still see mutations in the flora and fauna of Chernobyl, and even some mutations in humans because of how radiation damages the DNA. And in the picture at the bottom, you can see the drone footage of the current state of Chernobyl, and the picture to the right shows, again, reactor 4 after the fires were put out. Next slide, please. We decided to analyze the dilemma from a utilitarianism point of view, and this states that the interest of the masses is valued over the interests of an individual. So according to the Code of Ethics of the National Society of Professional Engineers, or NSPE, Bronkanov violated rule of practice number 1, which states that engineers shall approve only those engineering documents that are in conformity with applicable standards. He was the one that signed off on opening reactor 4 before the proper safety tests. And Topnov violated rule of practice 2A, which states that engineers shall undertake assignments only when qualified by education or experience in the specific technical fields involved. So he took an up position that he was not qualified for. And Dyatlov violated rule of practice number 1, which states that engineers shall hold paramount the safety, health, and welfare of the public. He did so when he demanded that the test continue despite seeing the risks involved.
All right, cool. So the impacts of the ethical issue, like I said earlier, that the government only took 24 hours to actually assess the real scale of this disaster. At this point, after these 24 hours, people were forced to evacuate and were only given around 50 minutes to pack and leave. This affected thousands of people in the nearby area. For reference, it was about 1,000 square miles is the area of ghost towns, the exclusion zone that Justin had mentioned previously. Government tried selling the crops and feedstock located in this area. However, experts warned them about all these consumer products being radioactive and not safe for the public to consume. The pictures on the bottom are people evacuating the area and how crowded it was, and they used buses and loaded trains to get people out as soon as possible.
So looking at these pictures, it shows some of the effects and results. The top left shows the Chernobyl exclusion zone, and you can see how close the city of Pripyat was to the nuclear reactor. The picture in the middle shows the sarcophagus that is currently covering the reactor to reduce the amount of radiation that escapes. The sarcophagus itself is meant to last for another 100 years, but radiation in Chernobyl is expected to last another 20,000 years. The picture to the top right is one of the most famous results of this disaster. It's known as the elephant's foot because it looks like an elephant's foot, but it's actually a mixture of melted concrete and metal that melted its way through the floor and is now resting at the basement of the reactor. And the three pictures at the bottom shows how radiation affects genetic mutations in animals, so you end up with extra legs. In the bottom right picture, they may look normal, but those are actually radioactive puppies that can contaminate you with radiation, so don't touch them.
All right, cool. So for alternative actions that could have prevented this, obviously from an ethical point of view, to further emphasize this, these are the ethical rules that should have been followed with greater importance. The NSPE rule of engineers shall hold paramount the safety and health and welfare of the public and issue public statements only in an objective and truthful manner. So, meaning a greater emphasis on warning from the engineers prior to the government's announcement would have reduced the amount of time the public was exposed to the radioactive particles.
Another NSPE rule they should have followed was performing services only in areas of their competence. So mainly for the engineers that made the mistakes firsthand, they should have had engineers in there with greater trainings than the ones that they were conducting.
Okay, and for outlook for future situations, to summarize, today's nuclear reactors tend to look back on previous ones that have failed, such as Chernobyl, to avoid the situations that they were placed under. The source of the problem at Chernobyl's nuclear power plant were the graphite rods that overpowered the system. In the United States, nuclear power plants don't use graphite rods, they all use water, so this problem is avoided altogether. And going further, the earthquake that happened in Japan not too long ago, there was a meltdown in the nuclear power plant, which is still being contained. So the Nuclear Regulatory Commission required all nuclear power plants to have plans in case of floodings or an earthquake. And some positive impacts and economic values. While there are only 103 nuclear power plants across all of the United States, few of those few produce 1/5 of the nation's electrical output. That comes out to 55% of America's clean energy. Not only that, but after the incident in Chernobyl and two others, nuclear power plants have been shown to be much safer today and much more efficient, having a greater power output. The average cost of the kilowatt hour is 13.19 cents. And in 2019, the nation's National Nuclear Power Plant produced 809 billion kilowatt hours. That comes out to all the money being made over $106 billion made last year, not including cost of operation or maintenance. And for the conclusion and summary, so in conclusion, the Chernobyl disaster is one of the worst in history, being 100 times more radioactive than the bomb in Hiroshima. To add, it is not the known issue to have caused the fall of the Soviet Union, but citizens did lose trust in the government's officials by not knowing the information that should have been released sooner, and they felt that the government would no longer be able to protect them due to all the health, environmental, and economic problems that arise afterwards of this situation. And some of the lessons to be learned after this incident of this magnitude were, if this were to happen again, the first responders should have the equipment ready to protect themselves. As in the case of Chernobyl, many of the people putting out the fires lost their lives or dramatically shortened them by the radiation exposed. And from a professional standpoint, engineers should not be pressured into doing something that's not safe. And as stated, it is our duty as engineers to prioritize safety and not let supervisors and politicians convince us to do so otherwise.
Great. Yeah, thanks guys so much. Yeah, really good job. Okay, so.
Sir, I have a quick question.
Yeah, sure, what's up?
For the first presentation, do we need, like, how many links we could add in our reference page at the end of the presentation?
You can add as many as you use. That's there's no limit to that.
Okay.
Okay. And so let's go ahead and keep it rolling. So our next group is the Kansas City Hyatt Regency. So is everyone here for that one?
Yeah.
Okay. Elvis, you're feeling okay to present, or?
I don't think he's presenting, but we
Okay.
have his
Got it. Okay. All right. So go ahead, guys, whenever you're ready.
Can you guys hear me? Okay. Good afternoon, everyone. My name is Arturo Gonzalez, and my group members' names are Elvis Walinas, Houston Tung, and Laura Melendez. We decided to choose the case study of the Kansas City Regency tragedy. We chose this case because we were already a little bit familiar with it, and it seemed interesting.
Alrighty, so in May of 1978, construction of the new Hyatt Regency Hotel began in Kansas City, Missouri. For this project, the Hyatt Corporation hired a local engineering firm, which was GCE, and that was owned by Jack Gillum. So Hyatt was expecting this 50-story luxury hotel to be pretty groundbreaking. They wanted a never-seen-before type of architectural design from the engineering team. And on July 1st of 1980, the Hyatt Regency Hotel in Kansas City had their grand opening. Next slide. However, only a year later, while many of the locals were gathering at the hotel's weekly tea dance event, 2 of the suspended bridges in the lobby's atrium area collapsed to the ground floor where hundreds of people were dancing. This event claimed the lives of 114 people and injured over 180, and it became the deadliest structural failure in American engineering history at the time. So the goal of this case study is to understand the design flaw as well as analyze how a lack of engineering ethics played a role in the aftermath of this event. Next slide, please. So during the building's first phase of construction, which commenced in 1978, Jack Gillum and his firm were still in the process of finalizing the hotel's design. And this approach of starting the project before the design was completely finished was a new approach the firm was testing out. And it was meant to be a lot quicker than a conventional building process. During the first year of construction, however, an incident occurred where part of the ceiling in the lobby's atrium broke off and fell onto the floor. So nobody was hurt and construction resumed shortly after. However, the event would prove to foreshadow destruction that would come soon after. Only a year into the opening of the hotel, 2 of the skywalks collapsed onto the crowd of people. Within the next couple days, the Hyatt Corporation started their own private investigations into the disaster zone. However, the Kansas City Mayor, Richard Berkeley, requested that the National Bureau of Standards, or known today as National Institute of Standards and Technology, conduct an independent investigation. Next slide, please. During their investigation, they found that the Kansas City building codes required structures to carry a maximum load of 448 kilograms per square meter. And the NBS was able to prove that there were 40 people on the upper skywalk and only 23 people on the lower skywalk. So with a total of 63 individuals, that would have only exerted a load of approximately 83 kilograms per square meter, which was far under the maximum load requirement. So therefore, the structure should have been sound enough to accommodate the amount of people that were on the walkways. And while the NBS was conducting, next slide, please. While they were conducting their investigation, so was Wayne Lischka, who was a local structural engineer hired by the Kansas City Star newspaper to go undercover in order to examine the scene further. And he found that the building plans, which had been approved by GCE, were not the same as what had actually been built by the Hyatt Hotel. He concluded that a second set of rods must have been placed on the upper walkway to carry the load of the lower skywalk, which means the upper walkway was carrying double its intended load, proving to be their fatal design flaw. And as you can see right there, the addition of the second rod design allowed for double of the load to be applied on the nut when it should have only been half of that. Next slide, please. The Kansas City Hyatt Hotel had an estimated overall building cost of $50 million. And although the first construction incident hindered their design timeline, they still managed to complete the project right on schedule with no cost of delay. However, because of the tragedy that occurred a year later, both the victims of the tragedy and families of those who lost their lives were awarded over $100 million in damages. Next slide.
I'll read over Elvis's slide in place of him. So the personal context, the people involved, Jack Gillum. He is the structural engineer with 10 years of experience and also the owner of Gillum and Calco, also known as GCE. He is the engineer of record for the project, meaning he would oversee all project details and would be held responsible for the entire project. Daniel Duncan is a structural engineer at GCE. He was in charge of the day-to-day on the projects and also responsible for designing and approving the building structure. He would have also seen the design flaw at one point of the project. Next slide, please. Richard Berkeley is the mayor of the Kansas City during the time of the incident and would contact the National Bureau of Standards, or also known as the NBS, to conduct the investigation. As a city official, it was Berkeley's job to get to the bottom of the incident. Edward Frang is hired by Berkeley and led the investigation conducted by the National Bureau of Standards. Wayne Lischka is the undercover engineer hired by the Kansas City Star to conduct his own investigation. Lischka was hired because the NBS was normally known to be busy, but the residents of the Kansas City requested immediate answers. Next slide, please. Description of the ethical lapse. The failure was due to the engineers failing to double-check their work and their designs. Daniel Duncan was the first engineer who failed to detect the load amplification. He went on and approved the fabrication methods without checking the new design. If Duncan would have checked the design, he would have possibly detected the flaw in the design. Jack Gillum would have also committed the mistake of not checking the design. As the engineer of record, he would have had the most responsibility to check the design and make sure everything was according to standards and plans. Instead, he simply believed his colleague had checked the design beforehand, when in fact, no one had checked anything. Next slide.
Analysis of ethical dilemma. You're good. The construction of the Hyatt Hotel was behind schedule. GCE was in a hurry to finish building the hotel that would have been seen as an attraction, since it had a lobby with an atrium. I guess back in the time, an atrium was not common to have in a building, so people were excited for that. However, speeding up a process for personal gain without thinking about the safety of the public becomes an ethical issue. There was a flaw in the design. The contractor decided to change the design and called Jack to get approval through the phone. So when the contractors were building the suspension rods, they assumed the design was final when it was not. They called Jack and explained to him that the design would not work. And Jack approved the new design without even doing any calculations to prove it was safe. Jack's negligence as the head engineer caused a worse design to be put into place and risked the safety of the public. But even though the plan was changed, the original plan was only compliance to 60% of the city's prescribed code requirements, meaning the disaster could have mostly still had happened. And these are some of the codes of ethics from IEEE and NSPE that were violated. The first one would be hold paramount the safety, health, and welfare of the public. And then another one would be engineers shall approve only those engineering documents that are in conformity with applicable standards. Impact of ethical issue. The steel company, construction company, and hotel owner paid over $100 million in compensation, and the court granted the victims insurance payouts. The responsible engineers and firms got their license revoked. Some of the firms went bankrupt. After Jack lost his license as an engineer, he would occasionally share his experiences with the hope of preventing future engineering mistakes. ABC News was intense. It covered moments of joy from the party to dead bodies being compressed. ABC News covered interviews of some survivors where they shared their horrific experience. And also ABC News titled the broadcast Moments of Crisis. And not only that, but also it changed engineering classrooms around the world, since professors would use the collapse of the Kansas City Regency Hotel as an example of what can happen and failure, and failure to catch flaws in design are not caught if they're not caught in time. And now these are some images of the impact. These are images of moments before the impact and moments after the impact. Hopefully this helps to better visualize the moments of horror that were present at the time. Not only that, but it is also important that as engineers, we note that a flaw in our design is not just a flaw, but an opportunity for disaster where lives are at stake. In other words, make decisions like if your life depended on it.
Some other possible ethical choices that could have been made. There are multiple opportunities where an ethical choice could have been made. Here, the focus will be on an instance where the structure had collapsed before its opening to the public. The mall project management ordered a structural review of the first instance where the bridge had collapsed in 1979. Engineer Jack Gillum and technician Greg Luth performed spot checks instead of what was originally asked for. Gillum had even approved the design after the subpar inspection he had performed. If they had performed the test thoroughly enough, they would have definitely determined the problem and lack of validation for the design. The engineer should have performed actions more aligned with the NSPE and IEEE codes. Sorry, that's a typo right there. Next slide, please. Integrity, responsible behavior, avoiding deceptive acts, being ethical and professional are standards that the engineers should have understood when they performed their task. Holding the safety and welfare of the public is the highest importance when designing something intended to be used by them. The engineers should have made every effort possible to minimize the chance of failure by checking their work multiple times, especially in regards to civil structures. The seal they placed to approve the plans for both the original and redesign of the box beam is negligent. Engineers should understand the consequences of failing to ensure the plans they have approved, meeting basic safety standards. Next slide, please. Outlook for future situations. If similar structural collapses occur in the present or future, a sequence of action will play out like that of the Hyatt, Kansas. The legal proceedings, loss of trust, and end of business are to follow. Most of all, it will be remembered just like the Skywalk collapse. Engineers will continue to be held to higher levels of accountability if similar failures occur. The legal standards may shift towards increasing liability into criminal punishments. The public may begin to distrust engineers and their creations. The impact on companies from the lawsuits and liability will be financially debilitating. In addition, the reputation of the companies involved will be diminished, stakeholders will be less likely or will completely stop working with the business. In the modern day and age of information where strong negative reviews can destroy a major business, accountability and honesty will require constant practice. Lastly, a more recent civil structure failure in the US, the FIU pedestrian bridge, has a very similar story to the Hyatt, Kansas. The Florida International University experienced a pedestrian bridge collapse on March 15, 2018. This federally funded project experienced failure due to the design underestimating the actual expected loads. The various instances where the structure exhibited growing cracks during construction, the bridge failure resulted in 6 deaths and 8 injuries. There have been continued lawsuits for the companies and contractors involved at both the state and federal level. This situation exhibits similar action and response as discussed in the Hyatt Regency, which shows that no matter the technology or advancements we make, there's always a human and ethical professional element that contributes to the end results. Next slide, please. In summary, on July 17, 1981, a newly built walkway collapsed in the Hyatt Regency Hotel in Kansas, Missouri, resulting in 114 deaths and more than 180 injuries, being one of the most fatal engineering structural failures in modern times. The structure was not properly designed to carry the necessary loads, and no action was taken to correct this. There are many opportunities to discover the issue, however, the consistent lack of proper professional action by the engineers allowed for the issue to reach the final design. The key takeaway point is to validate the work and statements you make. Understand your responsibility to uphold the trust of the people in your work.
Great, thanks guys. Really nice job. Okay. And so with that, we have just one more group left. So it's going to be the group on the Ford Pinto. Okay. So is everyone here from that group?
Yep. Yes.
Okay, so if you guys are ready, go ahead and share your screen, and then you can start whenever you're ready.
So. Hi, everyone. My name is Agustin Valadez.
My name is Joshua Tafoya.
Mr. Mariano.
Drew Rios.
And then we got Jonathan Madrano.
Oh, sorry, my mic is muted.
So next slide. And our project's going to be on the Ford Pinto side. All right, just a quick introduction. The Ford Pinto was designed and produced by the Ford Motor Company in the 1970s, and it's a pretty famous ethical case study in engineering. The Pinto had a very rushed design process to beat like other competitors in the small compact market. And as a result of this rushed design, the Pinto had like several safety flaws, the biggest of which being the gas tank would explode when hit from the rear, as you can see in that picture. It's a little staged, but the idea is basically there. And the real ethical issue with this is the real ethical issue with the Pinto is that Ford knew the danger the car posed to the public, and they refused to fix the safety flaws and the gas tank and everything. And they said it would be cheaper to pay the victims of that the car hurt instead of paying to redesign the car, since it was already designed. Next slide.
Okay, some historical context. Before the late 60s, Ford and other American car brands were leaders in the car industry. But then there was an emergence of foreign companies producing successful subcompact automobiles. And in 1968, Ford, a little threatened, started the production of the Pinto, and they planned to have it complete by the 1971 model year. At the time, it took about 3.5 years to get a car showroom ready, but they wanted to get the Pinto ready in about 2 years. Next slide, please. Before the production of the Pinto, Ford crash tested various prototypes to learn whether they met a safety standard proposed by the National Highway Traffic Safety Administration to reduce fires from traffic collisions. The prototypes all failed the 20-mile-per-hour test, and in 1970, Ford crash tested the Pinto itself, and the result was the same: ruptured gas tanks and dangerous leaks.
All right, so for some technical context here, production started in 1970 and it went all the way to 1980. For sales, it sold quite a bit. It sold over 3 million, and it was priced at $1,850 at launch for the first model. I have some specs here for that first model: 2-door sedan, rear wheel drive. It had a relatively light shipping weight, and then top speed of 141 kilometers an hour. Here are the values sold by year. You can see that there's like, it caps at 1974, and then it's a decline after that, you know, when they start losing that reputation. So the development, the initial planning started in 1967, and then it was recommended by the planning committee in 1968, approved by the board of directors in 1969. So this design here went from production, from concept to delivery in 25 months, which was unheard of at the time. At the time, the longest, I believe, was 43 months. And they did this by performing the steps in the development process like at the same time. They used, in particular, machine tooling overlapping with product development. So this locked in their design because they started building the parts before previous parts were ready. So they couldn't change any designs. In the following years, they had updates, little minor improvements. They had the cosmetic updates mostly. We had the hatchback, the station wagon debuted. They even had some appearance options, which were offered as a premium. But in 1974, to meet federal regulations, they added that 5-mile-per-hour bumper to the front and rear, which isn't even that good, 5-mile-per-hour bumper. And then, so they had some recalls as well. October 30th, 1970, 2 months after release, 26,000 Pintos are recalled. In March 1971, another 220,000 Pintos are recalled. And then on June 9, 1978, Ford recalled 1.5 million Ford Pintos and Bobcats to end public concern about the fuel system. These are just some various models of the Ford Pinto, some hatchbacks, different styles and designs that they had, and then in 1975 they even renamed the model of the Pinto as the Mercury Bobcat to give it a different name, you know.
So for economic context, the sales revenue that came from the Ford Pinto was estimated at around $2.9 million, alluding to it not being a profitable car. Ford's market shares during this time dropped from 12% to a low of 6.7%. Next slide, John. Ford's marketers try to save the drastic drop by appealing to consumers and promoting the price being a low of $2,000 in comparison to its competitors at the time, that I believe was JDM. This did help Ford a little bit. It brought their market shares from a 6% up until a 9.7%, and then that increased the production of Ford Pintos from 125,000 to 325,000 within that time frame of the 1970s, early 1980s, and this didn't really help the sales though, because regardless, the car had to reach its original 10-year planned cycle of production. Next slide. So Ford did perform a cost-benefit analysis, which we learned in this class. They showed that making the car safer was 49.5 million. That would have been the benefit of doing that, and then in the total cost would have been 137 million. So the way they were going to do this was they had to invest $11 more per car to make it safer. So this would have made the cost 2.5 times larger than that of the benefit. So we obviously at the time they thought that was too much, but this was nothing in comparison to the legal settlements and negative publicity that was going to bring down their sales and revenue in the future.
So for the personnel context, Ford, the team of Ford engineers designed the Ford Pinto. However, the president of Ford at the time, Lee Iacocca, put immense pressure and requirements on the design team. Basically, he didn't want the Pinto to be, or he wanted the Pinto to be as affordable as possible, no more than $2,000, and he wanted it as light as possible, no more than 2,000 pounds, which is really light. And it was worth mentioning that Iacocca wasn't an engineer; he was more of a business-oriented president, and he really wanted the Pinto to be very profitable. So to maximize profits, they cut corners and rushed the design process. He wanted. The attitude of Ford management was to design the Pinto as quickly as possible, and Iacocca had so much involvement with the development that it became known as Lee's car. And when it was discovered the fuel tank placement was faulty, that it caused the car to explode and whatnot. Instead of changing the design, he was quoted by saying safety doesn't sell, and just push forward, ignoring the safety concerns. And it's pretty clear that Lee Iacocca had no interest of the company before. He had the interest of the company before the safety of the public, which is not good at all. Next slide.
So why was the Ford Pinto so bad? Here's a little schematic in all of its glory. It just highlights some of the negative aspects of it. So it didn't use a frame to help protect the fuel tank in the earlier models. The door would jam in a rear collision, preventing escape. So if you got hit in the back, it would jam your door on the side. It had the weak bumpers, and then it added those other bumpers, the 5-mile-per-hour bumpers, and then obviously the fuel tank was too close to the rear, making it susceptible to explosions during moderate to low-speed collisions. In 1971, Ford Pinto, like we said, they rushed production in a response to the growing popularity of imported smaller cars. So like we had initially stated, Lee Iacocca wanted the car to cost less than $2,000, less than 2,000 pounds. So he ordered that the development be rushed, so that it could make the showroom for 1971. He insisted that without an alternative for the VW Beetle, the Japanese would capture the entire American sub-market. Safety was not mentioned in the product description, and crash tests conducted prior to production revealed that 8 out of 11 Pintos suffered potentially catastrophic gas tank ruptures. And this led to the reports that range from 27 to 180 deaths caused by the rear impact related fuel fire. So that's just related to the fire, not overall.
So one alternate course of action that Ford Pinto could have done or considered was definitely doing that investment, of $11 more per car. This would have made the vehicle a lot more rupture protected. This would have also regained customer confidence in the company. And this matters because in order to sell a product, you need customers to trust in your company and that, they're going to get a quality product. Not only that, but obviously, it would save human lives, and this has no value, of course. So next slide. So another course of action that they could have done in the very first incident, not wait for a few as they did, is they should have immediately recall all vehicles, not do it in increments as mentioned earlier. This would have gained customers' trust in the company because it would have showed that the company is responsible, hence customers are more inclined to go to you. And also it would have set an example in the auto industry because it would show customers that your company has good morals and are willing to own up to take action instead of avoid the issue. Hence, other companies will need to respond in the same actions if they want, if they want to keep their clientele. Also, again, worth mentioning, recalling would have saved more lives as opposed to saving none. Next slide, please. And then the third course of action. So we do have a National Highway Traffic Safety Administration, and they're the ones that inspect the vehicles, and they once you make them, you can either you can sell them or you have to work on them up until they meet the safety standards. However, these people they're not engineers, so as the professor mentioned, the public doesn't know the knowledge that engineers have. So I think another course of action that they could have probably done is have a third party, such as other engineers, check their work, and because the public tends to care more about style as opposed to safety. Next slide.
Analysis of ethical dilemma. Ford knew that Pinto represented a serious fire hazard when struck from behind, even at low speeds. The officials had to make a decision whether to continue with the existing design, meeting their timetable, or by putting consumer safety in jeopardy, or delay production by redesigning the gas tank to make it safer. In the end, they wanted to meet their timetable, and their knowledge of the faulty design and its risk to public shows their disregard of the code of ethics pertaining to public and their welfare. Next slide, please. So in the IEEE first ethical standard, to hold paramount the safety, health, and welfare of the public, to strive to comply with ethical design and sustainable development practices. Next slide, please. They relied on cost benefits reasoning over ethics. This cost benefit reasoning is analysis of the expected costs and the benefits of doing something. There are various ways of making the Pinto's gas tank safer. Estimated price of safety improvements were only $5 to $8 per vehicle, and Ford evidently concurred that the increased costs outweighed the benefits of a new tank design. Next slide, please. So IEEE third ethical standard, they didn't really abide by to support colleagues and coworkers in following this code of ethics, to strive to ensure the code is upheld, and to not retaliate against individuals reporting a violation. Next slide.
All right, just to wrap this up, this is the impact of ethical issues. The Ford Pinto was produced in 1968 and released in 1970, as one said earlier. Lee Iacocca rushes engineers to produce the Ford Pinto and demanded to be 2,000 pounds and at a cost of $2,000. This rush car resulted in a number of engineering design flaws, and the underlying issue was the placement of the fuel tank. So we have a little video right here, and it kind of shows you what happens in a collision. So John, if you could just please play the video.
the new Pinto 3-door runabout. Pure Pinto, front to back. And Pinto is built to go, go, and go. See the new Pinto 3-door runabout at your Ford dealer. Packs more fun, 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 packs more fun than any little.
All right. And then here are the pros and cons, just a general view of the pros and cons of the placement of the fuel tank. So one pro is the fuel tank is less likely to intrude into the car cabin space in an event in a collision. And one con is it is highly likely for the fuel tank to rupture in rear collisions involving speeds as low as 20 miles per hour. So this is kind of a schematic that John once showed, but this kind of goes into depth. On the right-hand side, you can see the ridge fuel tank on the bottom that's in black. And then, so in a collision, the bumper would ultimately hit the fuel tank, and then it will also hit the axle housing, which is in gray right there. And that would ultimately result in a rupture in the fuel tank and spill gasoline everywhere, which that's for sure a fire hazard and ultimately blow up the car. Go ahead and next slide.
All right, you guys are out of time, so so let's go ahead and kind of wrap it up.
Okay, so this is the first underlying case, and basically what happened was Lily Gray and her 13-year-old neighbor were traveling in their Ford Pinto and ultimately got struck by a car from behind that was going 30 miles per hour. And the result of the case was that Lily ultimately died, and Richard Grimshaw had 3-degree burns over 90% of his body. The Gray family got $560,000 from the Ford Motor Company, and the Grimshaw family got $2.5 million in compensatory damages and $3.5 million in punitive damages. And just there's an idea of what a 3-degree burn looks like. So this graph shows the fatalities per million of cars in 1976 in the Ford Pinto. As you guys can see, it's not that bad of a car. However, when it was compared to how it could produce like a fatal fire issue, it was, I'm sorry, I'm choking up. The result of that was 500 to 900 fatal fires that the Ford Pinto resulted in. Next slide.
So today, this would not fly. There are so many rules and regulations that you have to abide by before you put out a car. To this day, Pinto still has a negative legacy associated with its name, but Ford kind of got their reputation a little back.
All right, in conclusion, in 1974, NHTSA started an investigation against the Ford Motor Company. This resulted in a recall on all Ford Pintos in 1978. However, it failed to hold corporate leaders to be criminally responsible. Finally, in the 2000s, the Transportation Recall Enhancement, Accountability, and Documentation Act, TRED Act, was passed, and this established criminal liability to auto executives. However, it still limited its reach because companies are still able to benefit from having considerable flexibility and time to fix any safety issues. Still today, sadly, the motor companies still blame drivers for their safety flaws. What we can do as drivers is check our VIN numbers for any recalls and then ultimately fix them if there's any. The moral of this case is fast and cheap rarely results in perfection. And that's it.
Great, thanks guys. All right, so that concludes all our presentations. So so everyone did a really great job. So so thank you guys, for putting in all the work for those presentations. And so remember, I saw a few groups have turned in their slides. So, you know, if you want to touch up your slides a bit, you can go ahead and do that. Just make sure you submit them before Friday, and then I'll look through the slides one more time and give you guys your grades on the presentation. Okay. And so with that, you know, since this is the last time we'll be together, you know, I just want to take a moment just to thank everyone, you know, for a really great semester. You know, I know that it's, you know, this semester is always, we're always going to look back on and see how strange this was, you know, to do this all virtually. But, you know, and I know kind of the virtual instruction put a lot of strain on you guys too. So it's, I really appreciate all the work that you guys put in, all the hard work, you know, and as an instructor, it's always really great to see, you know, students put in that work for you guys. Okay, so, you know, since the last time, you know, I hope everyone has a great winter break. You know, stay safe, stay healthy out there. You know, if you have any questions about the project, or, you know, just any questions just in general, you know how to contact me. You have my email, you have my Discord. So, you know, stay good, everybody. Yeah.
Thank you for being a great professor.
Thanks, guys. Thank you.
Thanks, Prof.
Yep.
Thank you so much.
Thank you, Professor.
Thanks, guys.
Thank you.
Other professors should learn from you.
Thank you.
I agree.
Thank you. Thank you. Appreciate that.
And that's not to kiss ass, by the way. That's like real talk.
Thank you. I appreciate that.